Hello, good day. You're welcome to my channel. Please subscribe to my channel for additional teachings as stated. Today, we're going to be discussing surds. Before we move into our discussion, it is very important that you understand what perfect squares are. So, what are perfect squares? We need to list at least the first 15 perfect squares. To think of perfect squares, there are numbers whose square root give a whole number. So the first is 1. How? 1 times 1. The next is 4. 2 times 2. The next is 9. 3 times 3. 16. 4 times 4. 25. 5 times 5. 36. 6 times 6. 49. 64. 81. And so on. So these are perfect squares. Having understood what perfect squares are, we can now move into surds. The square root of a number other than the perfect squares gives a surd. So examples of surd include root 2, root 3, no 4, root 5, root 6, root 7, root 8, no 9, root 10, root 11, root 12, root 13, root 14, and so on. So when we talk about surds, we're talking about square root of numbers, but not that of perfect squares. So having known what perfect squares are and surds, we now move to simplification of surds. How do we simplify surds? Not all surds can be simplified. Certain conditions must be satisfied before a surd can be simplified. Of the examples here, only root 8 and root 12 can be simplified. Others cannot be simplified. Let's take the first, which is root 8. To simplify root 8, all you need to think of is two numbers that will give 8. One out of the two numbers must be a perfect square. So all I need to think of is root 4 times 2, because 4 times 2 gives 8. And one out of these two numbers is a perfect square. I did not start with 2 times 4. It is very important to start with the perfect square before the other number. So square root of 4 gives 2 root 2. When root 8 is simplified, what you have is 2 root 2. Let's take a second example, which is root 12. One might be tempted in simplifying root 12 to use 6 and 2. If you take a look at the list of perfect squares, 6 and 2 is not a perfect square. So in trying to simplify root 12, you cannot use 6 and 2. So the next option we are left with is 4 and 3. Take note, I didn't start with 3 and 4, but 4 and 3, because 4 is a perfect square. On simplifying, this now gives 2 root 3. So simplifying root 12 gives 2 root 3. Let's take one more example before we say bye to simplification of surds. Another example that I'd like us to take is root 98. So for 98, you need to think of two numbers which when multiplied will give 98, and one out of the two numbers must be a perfect square. Since 98 is an even number, try dividing by 2. When you divide 98 by 2, what you will get is 49. And 49 being a perfect square makes root 98 root 49 by root 2. Take note again, I didn't start with 2 before 49, but I'm starting with 49 before 2. So root 98 is the same as root 49 times 2, which when simplified gives 7 root 2. Okay, so let's move to addition and subtraction of surds. Two or more surds can be added together or subtracted from one another if they are like. 2 root 3 and 5 root 3 are like. Why? Because what you have in the root is the same. 2 root 3 and 3 root 2 are not like surds. Why? Because what you have in the square root sign are different. If what you have in the square root sign is the same, then we say the surds are like. Know that only like surds can be added together or subtracted from one another. So let's take an example. Simplify the following. Number one, 4 root 3 minus root 12. If you're asked to simplify 4 root 3 minus root 12, you need to check this root 12. Can it be simplified? Yes, it can. So taking the simplification process, this gives 4 root 3 minus. To simplify root 12, you need root 4 times root 3. So what I now have is 4 root 3 minus 2 root 3. When you simplify root 12, what you have is 2 root 3. You can now see that both surds are like. Originally, it looks like they are not, but after simplifying, you can see that the surds are now like. Imagine you're asked 4 eggs minus 2 eggs. What do you have? 2 eggs. So in this process, 4 root 3 minus 2 root 3 gives 2 root 3. Why? Because 4 minus 2 gives 2. The root 3 is the form, just like having 4x minus 2x. What you have is 2x. So 4 root 3 minus 2 root 3 gives 2 root 3. Let us take a second example. Let me get a more complex example.
Right.
Okay. The second example is simplifying 2 root 8 minus 3 root 32 plus 4 root 50. Picking a bit complex example, 2 root 8 minus 3 root 32 plus 4 root 50. Root 8 can be simplified. That gives 2 times. For root 8, you have root 4 times root 2 minus. For root 32, you have 16 times 2. Then for 50, you have root 25 times root 2. This gives 2 times 2 root 2 minus 3 times root 16 gives 4 root 2 plus 4 times root 25 gives 5 root 2. So taking the process, remember simplifying root 8 gives 2 root 2, simplifying root 32 gives 4 root 2, simplifying root 50 gives 5 root 2. So multiplying the last process gives 4 root 2 minus 3 by 4, 12 root 2 plus 20 root 2. Again, taking a look at the question, it didn't look at beginning like, but after simplifying, you can see the surds are all like. It is usually best to add before subtracting. So 4 plus 20 gives 24 minus 12, 12 root 2. So when you simplify 2 root 8 minus 3 root 2 plus 4 root 50, what you have is 12 root 2. Definition of surds. Before you can multiply surds, you need to know the rules for multiplication. And the rule states square root of a times square root of a gives a. Square root of a times square root of b gives square root of ab.
Second edition, so that they will still do the needful.
So for multiplication, our rule as stated, the first example is root 5 times root 10. So to carry out this, all you need to do is simplify root 10. That gives root 5 times 10 is root 5 times root 2. 10 is root 5 times root 2. So root 5 times root 5 gives 5 root 2. When you simplify root 5 times root 10, all you have is 5 root 2. A quick look at the second example. If you're asked to simplify root 6 times root 8 times root 10 times root 12, all you need to do is write the numbers in a form that there can be replication. I have root 6 For root 12 is same as root 6 by root 2. For 8, same as root 4 times root 2. Then for 10 is root 2 times root 5. All I've done here is to split the numbers. For 8, it becomes 4 times 2. For 10, 2 times 5. And 12, 6 times 2. So I'm going to pick the numbers in 2s now, meaning 6 and 6. Root 6 times root 6 times root 4, then times root 2 times root 2. What's left? 5 and 2 times root 5 times root 2. For a check, I'm picking the 2, 6, then 4 being a perfect square. I'm picking in 2s, root 2 times root 2, then the last 2, 5 and 2. If you multiply root 6 by root 6, it gives 6. We know root 4 is 2. If you multiply root 2 by root 2, you have 2. Since these 5 and 2 are not like, what you have is root 10. So 6 times 2 gives 12 times 2, 24 root 10. So when root 6 times root 8 times root 10 times root 12 is simplified, what you have is 24 root 10. Surds. If a fraction has a surd as the denominator, it is usually best to rationalize the denominator. How do we rationalize the denominator of the surd? Let's take an example. Simplify the following: 2 over root 2. If you take a look at this fraction, we have the denominator as a surd. So how do we rationalize? All you need to do is repeat 2 over root 2 times root 2 over root 2. In so doing, you are rationalizing by multiplying by the denominator over the denominator. 2 times root 2 gives 2 root 2. Root 2 times root 2 gives 2. The 2's can cancel out, giving you the final answer as root 2. So when 2 over root 2 is rationalized, what you have is root 2. Let us take a second example. You're asked to rationalize 7 over root 18. If you take a look at the denominator this time, we have a surd that can be simplified. So what we need to do is simplify the denominator. That gives 7 over root 9 times root 2. That now gives 7 over 3 root 2. If root 18 is simplified, what you have is 3 root 2. At this point, because the denominator is a surd, you must rationalize by writing 7 over 3 root 2 times root 2 over root 2. That's what it means to rationalize, by multiplying by what you have there. So 7 times root 2 gives 7 root 2, and 3 root 2 times root 2, remember root 2 times root 2 gives 2 times 3, 6. So when 7 over root 18 is simplified, you have 7 root 2 over 6. Again, the rule for rationalizing, you do not want the denominator to be a surd. From the beginning, the denominator is a surd, but after rationalizing, the denominator is no longer a surd. Surds are to be multiplied involving brackets. We use the usual rule for a plus b, c plus d. The rule says a multiplies c, a multiplies d, b multiplies c, b multiplies d, giving ac plus ad plus bc plus bd. So if I have a surd of this form, 2 plus root 3 multiplying 2 plus root 3, the same rule applies here. 2 times 2 gives 4. 2 times, or preferably, let's take the expansion method, 2 into 2 plus root 3, then plus root 3 into 2 plus root 3. This multiplying the whole bracket, then plus root 3 multiplying the whole bracket again. 2 times 2 gives 4 plus 2 times root 3 gives 2 root 3 plus root 3 times 2 gives 2 root 3 plus root 3 times root 3 gives 3 from our rule in multiplication. So collecting like terms, because not all surds here are like, gives 4 plus 3 plus 2 root 3 plus 2 root 3. 4 plus 3 gives 7. 2 root 3 plus 2 root 3 gives 4 root 3. So expanding 2 plus root 3 by 2 plus root 3 gives 7 plus 4 root 3. Two binomial surds conjugate is when they differ in sign. So if I have 2 plus root 3, the conjugate of 2 plus root 3 is 2 minus root 3. The conjugate of 2 minus root 3 is 2 plus root 3. The conjugate of 5 root 2 minus 2 root 5 is 5 root 2 plus 2 root 5. The difference is just in sign for the surds to be conjugate. If you're asked to multiply conjugate surds like 5 root 2 minus 2 root 5 multiplying 5 root 2 plus 2 root 5, you no longer employ the usual concept of multiplication involving brackets. Instead, you employ the concept of difference of two squares. Why are we employing the concept of difference of two squares here? Because both surds are conjugates. Having confirmed that both surds are conjugate, all you need to do is 5 root 2 all squared minus 2 root 5 all squared. Why can we go straight? Because they are conjugates. If they are not conjugates, then you'll be forced to take the usual expansion of this multiplying this multiplying this multiplying this, and this multiplying this. But because they are conjugates, you don't need to do this again. Having seen that they are conjugate surds, all you need to do is take the square of each. So this becomes 5 times 5, 25. Root 2 times root 2, 2. So 25 times 2 gives 50. Again, 5 times 5, 25. Root 2 times root 2, 2. That gives 50. Minus 2 times 2, 4 times root 5 times root 5, 5, giving 20. 50 minus 30 is 20. So when you multiply this, you get 30. That quickly takes us back to division again, involving, if you're asked to simplify 1 over 3 minus root 2, remember again, the rule says the denominator should. The rule here is to rationalize. Since the denominator is a binomial surd, we will rationalize using the conjugate. And the conjugate of 3 minus root 2 is 3 plus root 2. So simplifying 1 over 3 minus root 2 becomes times the conjugate of 3 minus root 2, which is 3 plus root 2 over 3 plus root 2. 1 times 3 plus root 2 gives 3 plus root 2. But because the denominators are conjugate, we employ the same concept, 3 squared minus root 2 squared, giving our numerator 3 plus root 2 over 3 squared 9, root 2 squared 2. 3 plus root 2 still remains 3 plus root 2 over 7. So when 1 over 3 minus root 2 is rationalized, what you have is 3 plus root 2 over 7.